right, it's day 5 of Colt's Corner. Today we're going to be using the kit that has the pattern blocks. You should have also had some task cards. There were several pages of task cards. We're going to be using those today. And you should also have a game board called the Flower Power game board. You'll probably also, on the back of it should be the Predator game. And we're going to learn both of those games a little later on. But before we get started, let's think about some ideas that are pretty common throughout mathematics. And when we see these pattern blocks and we talk about the word pattern, you know, we need to think about what is a pattern. There's a lot of different ways that we can make patterns and the ways that we use and see patterns in the world. So when you think about a pattern, what are some things that come to mind? I think about number patterns, most likely, when I'm thinking about math. If today we'll talk about shape patterns. You can look for patterns in nature. Patterns are things that repeat over and over. They're rules that are not necessarily made, but they're there. They exist. So we have to use our thinking and our strategies to help us find patterns in mathematics. And in all reality, that's what makes mathematics easier, is when you can find the pattern. How do you use those patterns? Well, we use them because once we identify a pattern, for example, an addition pattern, if you had a simple problem like 2 plus 4, then the rule or the pattern is plus 4. So if any number that you use, whether it be 2, 4, 6, or 8, if you add 4 to that, then you can create a repeating pattern. If we wanted to create a repeating pattern with these blocks, we could use all red, or we could use all blue, or all green. And then each of these blocks has a distinct color, so it would create a distinct pattern. So you could use them in combination. So you could have a combined pattern like blue, red, yellow, green. So patterns are everywhere, and they're fun to make and they're fun to play with. I think when I think about patterns, I think about quilts that are handmade. The quilter, the person who's making that quilt, they have to create a pattern, and then they use that same pattern over and over and over again to create a bigger piece or a larger piece. And that plays really well into what we're going to be doing with our pattern blocks today. So when you take your pattern blocks out, you can take them out one at a time. We'll start with the largest piece. This is the yellow hexagon, okay? And how does it get its name? Well, it gets its name because it has attributes. What are some things that we know about this yellow piece? Well, it has 1, 2, 3, 4, 5, 6. It has 6 sides. Hexa means 6. It also has 6 angles. So where these two lines intersect, these are known as angles. Okay, so 6 sides and 6 angles. It's a closed figure, so it is a polygon. Okay, so any closed figure is known as a polygon. So that's a yellow hexagon. Our red piece, it has some distinct attributes. It looks really different. Okay. It has 4 sides. It also has 4 angles. And its name is a trapezoid. Our blue piece, lots of you probably want to call this a diamond, but it's actually a blue rhombus. Okay, it also has 4 sides and 4 angles, just like the trapezoid, but it's a little different. What makes it different? Well, the rhombus has 2 sets of parallel sides. Parallel means that this line and this line will go on. You could extend it on and on forever, but they would never run into each other. Okay? They would never meet. So they also have this line and this line. So these two lines are parallel because if you were to extend them, they would never meet. Okay? So while this figure, this blue rhombus, has two sets of parallel sides, this red trapezoid only has one pair of parallel lines. Let's take a look at that. If we were to extend this line and this line, see how they intersect? They would cross. And you can do this little experiment with your fingers. They're going to meet each other. So these two lines are not parallel. They'd be intersecting lines. But this line and this line will be parallel because if we were to extend them, they would never meet each other. See? Okay? So that's the difference between a trapezoid and a blue rhombus. Then we have a green. That's right, it's a triangle. It's a triangle because it has 3 sides and 3 angles. Those are its attributes. We can use these in any combination to create other pieces, and that's going to be part of your lesson today in your explorations. If you take a look at your yellow hexagon, okay, then let's talk about, are there other ways we could make the yellow hexagon? Take a look at some of your pattern blocks and see if there's another way to make the yellow hexagon. If you said you could use 2 red pieces, you are absolutely correct. Take a look at that. 2 red trapezoids, oops, are the same as or are equal to a yellow hexagon. Are there any other ways we could say we could make the yellow hexagon? Let's try with the blue. If we take those blue rhombus, let's see what we can do there. I'm going to set that down so I can show it to you. Okay, so it takes 3 of the blue rhombus to make 1 yellow hexagon. All right. I wonder if we can cover that yellow hexagon with the green triangle. Let's try that. We did it. Look at that. It will take 6 of the green triangles to make 1 yellow hexagon. There you go. So did you notice any patterns? Or what did you see or what did you notice as you were building these different, building the same shape with different pieces? Well, one of the things that I noticed is that it takes 2 of these red trapezoids to make 1 yellow hexagon. So if the value of one whole is yellow, then what is the value of each of these red trapezoids? Yes, that's right. It would be 1/2 because we have 2 pieces here. So now we're using polygons and problem solving to enter into the world of fractions. It's a great introduction to fractions. So knowing how you can change, knowing how to use these pieces to help you find different ways to make pieces can help you become a more flexible thinker in mathematics. And so I want you to take some time today and explore some of that. And your task cards are going to help you do that. You look at the very first card, and it's exactly what we just went through. We just went through and talked about each of the patterns, what their names were, and then we talked about this challenge question says which two shapes can be joined so that the result is a polygon with fewer sides than the larger pattern block being used. So we worked through a few of those examples today. What I'd like for you to spend some time doing is going on and looking at some more of those task cards. You're going to be covering shapes with pattern blocks, and you're going to be asked to use the least number of pattern blocks to find, to cover. You'll be asked to cover different types of shapes in different ways. And I hope you'll take some time and have some fun doing that today. Also take some time just to use your pattern blocks and create pictures. You know, something that's fun to work with is symmetry. If any of you remember from your 3rd grade math learning, symmetry is just when you have a mirror image of a piece. So we could say, you know, if I created a picture that had 2 red and 2 green, okay, so if I put these together like this, then I could say that my line of symmetry, this is tricky, my line of symmetry is right down the middle right there, because this side is a mirror image of this side. So have some fun with this, spend some time creating pictures. Also know that there are some pattern block links that I've posted in day 5 that after you finish your task cards, then you can spend some time taking a look at and making some other pictures. They're very similar to your tangram task that you had last Thursday, but this time you're going to be using your pattern blocks to create pictures. So dig in and have some fun with math, and we will see you tomorrow.